Welcome to T1 Academy. What is meant by face value and place value? Our next concept is based on face value and place value. This is very simple and basic concept. What is meant by face value? For example, there is a number 4362. 4362, there is a number. Now, what is meant by face value and place value? Face value means nothing but the number itself. Whatever the value it have, whatever the value of the digit it have, the same thing. So, the place value of digit 6, the face value of digit 6 is 6 itself. Now, when it comes to place value, what is meant by this place value? Place value is nothing but the position which we have in the given number. So, this is ones position or units position, this is a tens position, right? So, the place value of this is 6 into 10 which is equal to 60. So, the place value of this is 60 for us here, the place value is 60. So, for any given number, in any given number, for any particular number, if they ask you face value and place value, means face value it remains the same irrespective of its position wherever it is there in the given number. When it comes to place value, it depends on the position of the digit in the given number. So, there is only one type of question from this concept. What is the difference between place value and face value of? Okay, that type of question is, what is the difference between place value and face value of digit 3 in 3420. What is the place value and difference between place value and face value of digit 3 in the number 3420? So, now what is the place value? We have 3000. Why? Because that was 3 is in the thousands position. What is the face value of this 3? 3 itself. So, the difference between these two will become 2997. This is the only concept of this one. Okay. Next. This is very important concept. The next concept is factors. Factors. How you will find the factors? Before learning the factors, we should know what is meant by prime factorization. What is meant by prime factorization? That means nothing but to express any given number as the product of prime numbers, we call that as prime factorization. Okay, any given number can be written as the product of prime numbers. That means expressing the number as the product of prime numbers, we call that as prime factorization. We will see randomly. What is this prime factorization? Take for example 200. What I need to do is, I need to divide this with prime numbers. So, 2 hundreds, 250s, 225s and the next 5 5s, right. So, what it becomes? So, 200 is equal to 2 cube into 5 square. 200 is equal to 2 cube into 5 square. So, this process we call it as prime factorization. To express any given number in the form of product of prime numbers, we call that as prime factorization. Right. Now, we will see. Now, there is a number, if n is a number which can be written in the form of 2 power p, 3 power q, that is nothing but expressing it as in prime factorization. Okay. So, we are expressing the given numbers as 2 power p into 3 power q into, how we will do that one, how we will express in this format means nothing but by doing prime factorization. Then, the total number of factors, the formula for total number of factors is add 1 to the powers and multiply them. P plus 1 into Q plus 1 into R plus 1 into this is R plus 1 into S plus 1 and so on. Okay. Next, odd factors. See, apart from 2, all the remaining prime numbers are odd numbers. Apart from 2, all the remaining prime numbers are odd numbers, we know. So, odd factors means how we will find the odd factors? By adding them. Q plus 1 into R plus 1 by only neglecting the power of neglecting the power of 2, we will consider all the remaining powers. We will consider all the remaining powers except 2, we will leave the power of 2 and we will take the remaining powers and add 1 to them and multiply them. Next, even factors means actually we do not have any direct formula to find the even factors. We have the formula to find the total number of factors and we have also the formula to find the odd factors. So, simply subtract odd factors from the total number of factors, you will get the even factors. Next, the formula for number of prime factors means how you will find the prime factors means simply add the powers. simply add the powers. If you add the powers, you will get the number of prime factors. Next, sum of the factors and product of the factors, very rarely we will use. Very rarely we will use this one, but you should know the formula. The formula for that is 2 power p plus 1, nothing but 2 powers. P plus 1 minus 1 by 2 minus 1, 3 power q plus 1 minus 1 by 3 minus 1, and so on, like this. Okay, next, product of the factors, n to the power of number of factors of n by 2, number of factors of n by 2, number of factors of n by 2. Okay, right. Next, find the number of factors for 120. Find the number of factors for 120. Just now I told you we will do the prime factorization for 120. So, what we will get? 120, 2's are 60, 2 30's, 2 15's, 3 5's, right. So, after this what it becomes? First 2 cube into 3 power 1 into 5 power 1, 5 power 1. So, what is the formula we have? Add 1 to the powers and multiply them. That means 3 plus 1 into 1 plus 1 into 1 plus 1. Okay. So, 4 into 2 into 2. This will become 16 for us. This becomes 16. Next, find the number of odd factors for 90. Odd factors for 90. As usual, first we need to do the prime factorization. 90 to 45. Next 3 15's, next 3 5's. So, what I can write? 90 as 2 into 3 square into 5 to the power of 1. See, here we require only the odd factors. Odd factors means we will not consider the power of 2. We only consider the remaining powers. So, what you will write? 2 plus 1, that is power of 3 is 2, right. So, that is the reason I have written 2 plus 1 into power of 5 is 1. So, 1 plus 1. So, 2, what you will get here? 3 into 2. So, 6 is our answer. So, 90 have 6 odd factors, right. Find the total number of factors for the product 4 to the power of 5 into 9 cube into 5 to the power of 5 into 11 to the power of 8. Now, we need to find the total number of factors for this. Now, what I can write? 4 as 2 square whole to the power of 5 into 9, I can write this one as 3 square, 3 square whole to the power of cube into 5 to the power of 5 into 11 to the power of 8, right. So, 2 to the power of 10 into 3 to the power of 6 into 5 to the power of 5 into 11 to the power of 8. So, add 1 to the powers and multiply them. What you will get? 10 plus 1 into 6 plus 1 into 5 plus 1 into 8 plus 1. 8 plus 1. So, 11 into 7 into 5 into 9. The product, this is the product. If you multiply that, you will get the number of factors for this given number. Next concept, very, very important concept, units digit. Units digit. So, there will be many questions based on this units digit, especially not only in this railways, SSC, even in UPSC also they are asking at least one question from this concept called units digit. This is very, very important for us. Okay. Now, what is meant by this units digit? Okay. See here, for example, there is any product or any something like that, some 342 plus 746 plus 933 plus 745. This is a sum. I need to find the units digit of this sum. So, generally when you add these sums, what is the general mathematical procedure to add these terms? What is the general way? 342 plus 746 plus 933 plus 745. Usually what we people will do to get the units digit, we will add all these units place numbers. 2 plus 6 plus 3 plus 5. What you will get? 8, 11 and 16 and 1 will go as carry, right. So, the unit digit is what? 6. The general process is this. Or else the other way what we can do here is, see here, 2 plus 6, what it is? 8. Anyway, the same procedure. We are also doing the same procedure. Next, 8 plus 3. 8 plus 3 it is 11. We will not bother about this one. Why? Because we want only the units digit. I will continue with this one. Next, 1 plus 5 it is what? 6. So, our answer for this one becomes 6 here. If the question is based on the units digit of any sum, we will solve that one in this manner. Okay. Now, for example, if the question is based on product, the same thing. If I have for the same numbers, or I will little bit change this one, 746 into 933 into 947. I have a number something like this. I need to find the unit digit of this product. For the product also the same thing, how we have done for the addition. Okay. Here we have added, right? Here we have added, right, in the previous case. Now we will multiply that one. So 2 into 6, what you people will get? 12. We will not bother about this one. We will only continue with the units number, units digit. So next 2 into 3, what it is? 6, only one digit. So no problem, we will use that one. Next 6 into 7. 6 into 7, what it is? 42. We will not bother about 4, we will only go with 2. So the units digit of this product is what? 2. The units digit of this product is what? 2 for us here. So in this manner we will find the units digit of any product, units digit of any product. Okay, well and good, superb. If it is a general addition or if it is a general multiplication, you can do that one. But there are some special cases under this units digit. And remember one more thing, while solving in this manner, sometimes they may give us very huge questions, something like this: 2 into 4 into 6 into 8 into 10 into and so on up to 2000. If they given you a question something like this. See, previously those numbers are very, very small, we have done, that means the length of the number of numbers are only 4, we solved it. But please see here the numbers are very huge in number. Then how we will solve these type of things? It's very simple. In this product we have a 0, right? In this product we have a 0. 0 into anything, what it becomes? 0. So whenever you get a 0 in any product, at last also the unit digit will be what? 0 only. During the process, if you get 1 0, that is enough. Obviously the unit digit becomes what? 0 for us. For example, there is a question something like this. 545 into 342 into 725 or else 723 into 739 into 747. There is a question like this. What is the unit digit of this one? We all know 5 with any even number. Okay, when you multiply 5 with any even number, we will get units digit as 0. 5 2s 10, 5 4s 20, 5 6 30, 5 8s 40 and so on. So when you multiply 5 with any even digit, obviously you will get the units digit as 0. So whenever you see 5 in any question, our first thought should go on to the 5. And if there is 5, then immediately we need to check whether there is at least one even number. At least one even number is sufficient. We can say that the unit digit is 0. So here 5 and I have one even number which is 2. So I can say that my units digit will become what? 0. Only odd numbers are there and we have 5. That means for example, they will ask us a question in this manner. For example, what is the unit digit of product of all prime numbers below 130. This is the question. What is the unit digit of product of all prime numbers below 130? So we need to multiply the units prime numbers below 130. So what are the prime numbers below 130 do we have? 2 into 3 into 5 into 7 into 11 into 13 and so on. We need to write all the prime numbers up to 130. The length is very, very high, right? Very huge. So I have 5 with one even number. I have 5 and a even number. So 5 and even number, what is the units digit? I will have 0. For example, there is one more question similar to this one only. If they ask in this manner, what is the unit digit? What is the unit digit of all the odd prime numbers? Odd prime numbers below 130. If you use the word odd, if he uses the word odd, So now what happens to my data set? What happens to my data set? Okay, what will happen to my data set here? It will start from 3. We cannot take 2. Why? Because 2 is an even number. So 3 into 5 into 7 into 11 into and so on. From here onwards, all the prime numbers except 2, we know that those numbers are what? Odd numbers. So in previous case, I have 5 and 1 even number. So I have written units place as 0. But in this case, I will have 5 and I will have all the odd numbers only. So what will be my unit digit? 5 with any odd number. What is the unit digit? We will get 5. Okay. So while solving the question from this units digit, the most important observation which we need to make here is 5, digit 5. If you have the digit 5 at a units place, then immediately check if there is at least one even number. At least one is sufficient. Okay. If there are some 100 odd numbers and there is one even number, even digit also, then the units digit becomes 0. Okay. Like that. If there are no even digits, then obviously we will get the units digit as 5 only. Okay. Now find the unit digit in the product 621 something. Now just now I have told you, right. So I have 5 and I will check whether any even number is there or not in the given numbers. 1, 7 and 3. I don't have any even number. All our numbers are odd numbers. So my unit digit will become what? 5 here. Simple. Okay. Now, okay, if the questions are in these general products or something like this, it is very easy to solve. But in general, they will give us the questions based on powers. Powers in the sense means, what is the unit digit of some 343 whole to the power of 729? They will ask in this manner. So how we need to solve this type of questions? This is very, very important. Okay, this concept is very, very important for even the examinations conducted by UPSC also. Okay, right. See here, any number which ends with 0, irrespective of its power, whatever may be the power it may have. So what will be the units digit we will have? The units digit we have is 0. What is the example we can make is, for example, I will take 20 to the power of 48. Irrespective of length of the number. See, this indicates some 2D number, 3D number, 4D number, whatever it may be. Okay. So 20 to the power of 48. 20 to the power of 48. So what you will, the meaning of this is 20 into 20 into 20 up to 48 times, right? You need to write that for 48 times. So 0 into 0, 0 into 0, 0 into 0, 0. So whatever may be the number of zeros I have, so what will be the units digit? I will get 0. Right? Next. Any number which ends with 1. Irrespective of its length. Same. For example, if I have 21 whole to the power of some 48. What does it mean? I need to multiply 21 for 48 times. Right? So 1 ones, 1, 1 ones, 1, 1 ones, 1, 1. So like this, any number which ends with 1 also, irrespective of its power, you will get always the units digit as 1. And similarly, any number which ends with 5. Irrespective of its length, the same thing. Here also you will get always 5 only. Take 25 into 25 into 25. See here, for example, if you multiply 25 into 25 into 25 into 25 like this for n number of times. 5 5 is 25. Unit digit is 5. 5 5 is 25. Unit digit is 5. 5 5 is 25. Always you will get the same digit, right? So my answer is 5 only. Next, any number which ends with 6. Irrespective of its power, you will get the units digit as 6 only. So similar, if you take 26, what you will get? 26 into 26 into 26 into 26 like this, right? 6 6 are 36, unit digit is 6. Next 6 6 are 36, unit digit is 6. 6 6 are 36, unit digit is 6. Like this, irrespective of the length of the number, always you will get the units digit as 6 only. Right? Next. So total how many digits do we have? 10 digits. Total 10 digits we will have. So from out of those 10 digits, we are done with 4 digits. So what are those digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8 and 9. So these are the digits which we have. So from these digits only I need to solve the problem. So total 4 digits are there for us. 4 digits are we are done with 4 digits. We have more 6 digits. Now see here, in these 6 digits, what are the we will see the number which ends with 4. The number which ends with 4. So any number which ends with 4, digit 4, then here we will have 2 chances. What are those 2 chances? Means if it depends on n. If n is odd, if its units digit becomes 4 if n is odd. If the value of n is odd, then you will get the units digit as 4, and 6 if n is even. That means if the power, that means it depends on the power. If you have an odd power, you will get the 4. If you have an even power, you will get the 6. Try to remember in this manner. 4 power 1, what it is? 4. 1 is an odd number, so units digit is 4. 4 square, it is 16. 2 is an even number, so units digit is 6. Try to remember. So the reason is very simple. For example, there is a number 24 whole to the power of 40. So what you will do? 24 into 24 into 24 into 24, like this you will write, right? Now please observe here, 4 4s are 16. Next 6 4s are 24. Next 4 4s are 16. Next 6 4s are 24. If you observe like this, you will get 6 4 6 4 6 4 6 4 6 4. That means for 4 we will have 2 chances. One is 4 and the other one is 6. When you will get 4 means if n is odd number. When you will get 6 means if n is even number. And similarly, any number which ends with 9. So here also we will have 2 chances similar to our 4. Those 2 chances are 9 and 1. If n is odd, we will get 9. If n is even, we will get 1. Simple to remember. 9 power 1 is 9. 1 is an odd number. 9 square is 81. 2 is an even number. So when you have, what is the unit digit of 81? 1. So try to remember in this manner. Now please observe here, students. Out of 10 digits, 4 digits have only those digits as units place. 2 digits have 2 chances. Now we are left with what are the other digits? 2, 3, 7 and 8. 2, 3, 7 and 8 are the remaining 4 digits. Then how we will get the units digit for those powers? Now please observe here, from one observation we can write 2 power 1 is 2. I will write the units digit only here. Anyway, only 1 digit, so directly I am writing 2. 2 square, it is 4. 2 cube, it is 8. 2 power 4, units digit is 6. That means 8 into 2, 16. Units digit, what I will get? 6. Next, 2 power 5, 6 2s are 12. Units digit is 2. Next, 2 power 6, 4. 2 power 7, 8. Next, 2 power 8, once again 8 2s are 16. If you go on like this, the same numbers 2 4 8 6 2 4 8 6 will be repeated. Okay. Next, similarly, I will check the 3 powers. 3 to the power of 1, 3. 3 square, units digit. I am writing only the units digit. Once again I am repeating. 3 cube is 27, but units digit is 7. 3 to the power of 4 is 81, but units digit is 1. Or else you can write in this manner also. 9 3s are 27, units digit I have written 3. Next, 3 7s are 21, units digit is 1. Next, 3 power 5. So 3 1s are 3. Next, 3 power 6. 3 3s are 9. Next, 3 power 7. 3 9s are 27, unit digit is 7. 3 to the power of 8, 1. If you observe this one, what is repeating here? 3971, 3971, 3971. Okay. And similarly, for 7, 7 to the power of 1 is 7. 7 square is 49, units digit is 9. Okay. 7 cube is 343, units digit is 3, or else 7 9s are 63, unit digit is 3. Next, 7 to the power of 4, 7 into 3, 21. Units digit is 1. Next, 7 to the power of 5, 7. 7 to the power of 6, 7 7s are 49, unit digit is 9. 7 to the power of 7, 7 9s are 63, units digit is 3. 7 to the power of 8, 3 7s are 21, units digit is 1. If you observe 7931, 7931 is repeating. Okay. Next, 8 to the power of 1 is 8. 8 square is 64, but units digit is 4. 8 cube is 512, units digit is 2. Next, similarly 8 to the power of 4, 8 2s are 16, so 6. 8 to the power of 5, 8 6s are 48, units digit is 8. 8 to the power of 7, 8 8s are 64, unit digit is 4. 8 to the power of 8, 8 4s are 32, units digit is 2. Sorry, 1 2 3 4 5, sorry, 6 7. 8 to the power of 8, 8 2s are 16, so unit digit is 6. If you observe 8426, 8426, like this, the same thing will be repeated. So, for the first 4 digits, there are 4 chances. Next 4 and 9, for these 2 digits, we will have 2 chances. When it comes to 2, 3, 7 and 8, we will have 4 chances each. We will have 4 chances each. Then how we need to choose? Which one has the units digit means? See here, any question. For example, I will take an example. What is the unit digit of 232 whole to the power of 74? 232 whole to the power of 74. So, what is the units digit for me here? 2. So, for 2, how many chances do I have? 4 chances. So, simply divide the power with 4. Divide the power with 4. Okay. So, that means 74 by 4. And after dividing the power with 4, observe remainder. Observe remainder. So, when I divide 74 with 4, what is the remainder I will get? 2. I will get the remainder as 2. Now, take the units digit of this one. That means, you need to take the unit digit of 2 square. This 2 is here and this 2 is the given units digit. Units digit is 2 and the remainder is 2. So, I got this one. For example, there is one more question. So, 2 squares unit digit is what? 4. 2 square value is 4 and 2 squares unit digit is also 4. Okay. Next, 377 whole to the power of 141. Okay, 141 is there for me. So, for 7 also, how many chances do I have? 4 chances I have. So, same 141 by 4. What is the remainder? What is the remainder I will get here? 1. Remainder I will get is 1. So, 7 to the power of that remainder 1. What is the 7 to the power of 7? Sorry, 1, 7. So, the unit digit is here 7. Okay, it is fine. Okay, if the remainders are 1, 2, 3, you will do that one. For example, there is a question something like this, 238 to the power of 64. 238 to the power of 64. So, as usual for 8, how many chances do I have? 4 chances. For 8, how many chances do I have? 4 chances. So, I will divide the power with 4. That means, I will divide 64 with 4. 64 with 4. What is the remainder I will get here? 0. What is the remainder I will get here? 0. So, when you get remainder as 0, take the 4th power. Take the 4th power. The reason is very simple. That means, you need to take the units digit of 8 to the power of 4. You need to take the units digit of 8 to the power of 4. And the units digit of 8 to the power of 4 is 6. 6. If you don't remember the number also, it doesn't matter. Write 8 for 4 times and simply check the unit digit. 8 into 8 into 8 and check the unit digit. Why? Sir, why in case of remainder 0 we are taking 4 means, if you divide any number with 4, what is the highest remainder possible? If you divide any number with 4, the highest remainder possible is 3. So, getting 4 is not at all possible. That 4 is nothing but 0. That 4 is nothing but 0. Why? Because see, what are the remainders possible when you divide with 4? 0, 1, 2 and 3. This 0 we can also say it as 4. That is the reason, if you get the remainder as 0, take the 4th power. Else, if the remainders are 1, 2, 3, no issue with them. You can directly take the respective powers. But if the remainder is 0, take the 4th power. 4th power. The reason is, when you divide any number with n, the highest possible remainder is n minus 1. N minus 1. Okay. Next, we will solve some questions based on this. Find the units digit of 233 whole to the power of 41 into 242 whole to the power of 53 into 246 whole to the power of 21. Like this, they will ask us some questions. Now, what is the unit digit? For 3, we have how many chances? 4 chances. So, divide the power with 4. 41 by 4. What is the remainder I will get here? 1. So 3 to the power of 1 remainder I need to take into. For 2, how many chances I will have? Same as usual, for 2 also I have 4. So I will divide the power with 4. So 53 by 4, what is the remainder? I will get 1. So I need to write the unit digit of 2 to the power of 1. Next, for 6, irrespective of the number, irrespective of the power, if a number ends with 6, always the unit digit will be 6 only. So the unit digit of 3 is 3 power 1 is 3, 2 power 1 is 2 and 6 is 6 only. 3 2s are 6, 6 6 are 36. Right. So our answer here is 6. So our answer here is 6. In this manner, you need to find the units digit of the given numbers. Unit digits of the given numbers. Okay. Next one. The next and important thing in our concepts, in our number system concept is remainder theorem. Remainder theorem. What is meant by this remainder theorem? What is this remainder theorem? This is very, very important. Okay. As usual, I told you, in almost all the examinations, they are asking one question from the concept of this remainders. How we will find the remainders? Here we need to know two principles. Okay. What are those two principles? Generally, when you divide any number 17 with 5, what is the remainder you will get? Generally, when you divide any number 17 with 5, the remainder you will get is 17 divided by 5. We do in this manner. We will write our remainder as 2. Perfect. There is no doubt in that. But we can also do in this manner, right? 5 fours is 20. When I subtract here, what I will get here? Minus 3 as my remainder. So, technically speaking, both 2 and minus 3 are correct. Both 2 and minus 3 are correct. But when we write our final answer, we write it in a positive manner. That means what you will write? You will convert this into positive by subtracting it from divisor. So 5 minus 3, what you will get? 2. 5 minus 3, what you will get? 2. So here what we can say is, taking negative remainders is okay. But when you write your final answer, definitely you need to convert it into positive. Okay, that is the first rule. Negative remainders are possible. We can use them at intermediate level, but when we write the final answer, we always convert it into positive. How we will convert? Generally, we will simply subtract it from the divisor. 5 minus 3, 2, like this. This is the first rule which we should know here. Next, what is the second rule? What is the second rule? Means we can take the individual remainders. We can take the individual remainders. What is this individual remainders? For example, I need to tell what is the remainder for 121 plus 143 by 5. What is the basic method usually which we do is, we add 121 with 143. So, we will get the answer as some 264 by 5, and the remainder for 264 by 5 is 4. The remainder for 264 by 5 is 4. The other method to tell this one is, find their individual remainders. 121 by 5, what is the remainder? You will get 1. 143 by 5, what is the remainder? You will get 3. And what is the mathematical symbol between them? Plus. So 1 plus 3, what it is? 4. So anyway, we will get the same answer. So two things which we need to remember here is, first one is negative remainders are possible, but when we write our final answer, always we should convert it into positive. Right? Next thing is, we can find the individual remainders and apply the mathematical symbol between them. For example, if you have product here, that means 121 into 143 by 5. If my question is something like this, I need to find the remainder for this. So 121 by 5, what is the remainder? 1. 143 by 5, what is the remainder? 3. So 1 into 3. Our answer becomes here 3. So now here we need to keep few things in our mind. What are those few things means? Please observe here, 264, 5 and 3, right? First observation which we need to keep in our mind is, the remainder should be always less than divisor. For example, in some cases, if you get a value greater than divisor means once again divide it with the divisor, given divisor to get the answer. Okay, next, always positive. We should write always our answer in the remainder should be always positive. Okay, these two things, these are the major things of this remainder theorem. From these observations only, we will solve the questions. Find the remainders of few things we will see now. Okay. Next one. Now, what are these remainders and how we are going to use these remainders? Example, find the remainders of the following is the question for us. And the question is, (8 by 2). Okay, 3 to the power of 98 by 2. If this is a question. Now, in generally, to find 3 to the power of 98 is very time taking, not impossible, but it is a time taking process. So, what we will do is, we will not bother about this 98, we will simply find the remainder for 3 by 2. What is the remainder for 3 by 2? 1. So, 1, and now I will apply the power to it. So, 1 power 98 is what? 1. So, the remainder for 3 to the power of 98 by 2 is 1. 3 to the power of 98 by 2 is 1. Next, similarly, I need to tell the remainder for 2 to the power of 98 by 3. 2 to the power of 98 by 3. Now, as usual, what is the remainder for 2 by 3? If you know only the positive remainders, what you will say? 2. The remainder for 2 by 3 means what? The general method. 3 zeros are 0 and you will say it as 2. But if you know the negative remainders concept, what you will say? 3, 2, 1s are 3. And when I subtract it, what you will get? Minus 1. If you know the negative remainders concept, you will say that your answer as minus 1. So, here we will take the help of negative remainders. Here we take the help of negative. So, what I will get here? Minus 1 whole to the power of 98. So, minus 1 to the power of even number means what is the answer you will get? Plus 1. Plus 1. For example, the same thing is in this 2 to the power of 45 by 3. What is the remainder for 2 by 3? Minus 1. Minus 1 whole to the power of 45. So, minus 1 and odd power, what you will get? Minus 1 only. But will we write our answer as minus 1? No. We cannot write our answer as minus 1. We always write our answer in positive. So, what I will do? 3 minus 1, that is equal to 2. So, 2 will be our answer here. So, the remainder for 2 power 45 by 3 is 2. In this manner, we will write the remainders for the things. For example, okay, there is one more question, something like this. What it is 2 power 60 by 7. 2 power 60 by 7. Then how I need to find the remainder for this one? So, simple. Actually speaking, the difference between 2 and 7 is 5. If you ignore the power and try to do the problem also, it takes a lot of risk for us to solve this. But what I can do is, check the power of 2 which is nearer to 7. Which power of 2 is nearer to 7? 2 cube is 8, right? So, what I will do is, I will split this in powers of 2 cube whole to the power of 20 by 7. I can do in this manner. The reason is, I simply splitted this 60. We all know that a to the power of m whole to the power of n is equal to a to the power of m into n. Why I have splitted only in terms of 3 means, here my requirement is 2 cube. That is the reason I have written it as 2 cube. 2 cube whole to the power of 20. So, now what happens to this? 8 to the power of 20 by 7. So, now the remainder for 8 by 7 is 1 and 1 to the power of 20 is what? 1. So, we can easily tell our answer as 1, right. Next, similarly, what we can say is one more example. Two to the power of 34 by 9. 2 to the power of 34 by 9. Right, here also the same thing. Which power of 2 is nearer to 9? 8. So, I need to split the power in terms of 2 cube. 2 cube whole to the power of 11 into 2 to the power of 1 by 9. 2 to the power of 1 by 9, right. So, now what is happening in this case? Here my requirement is 2 cube. So, I have simply splitted the power, nothing more than that. See how I have splitted that one. I have 34. So, 3, my requirement is 3. So, 11 is 33 and the remainder is 1. So, 2 cube power 11 and the remainder I have written this remainder separately. So, now what it becomes 8 to the power of 11 into 2 to the power of 1 by 9 or else 2 by 9, 2 by 9, 2 by 9, right. So, now 8 by 9, what is the remainder for 8 by 9? Minus 1 whole to the power of 11 into, what is the remainder for 2 by 9? 2 itself, right. So, into 2. So, minus 1 whole to the power of 11, what you will get? Minus 1 into 2. So, what you will get? Minus 2. But we will write our answer in negative? No. So, what I will do? 9 minus 2. What will be our answer here? 7. What will be our answer here? 7. So, in this manner we will find the remainder for the things. Okay, well and good. In most of the cases, we can write the difference between numerator and denominator as 1. There is no doubt in that. Next, in our next sessions, we will see the problems based on how in some other examinations like RRBs, SSCs, in all those, how they have asked the questions from this units, digits and remainders, we will see them. Okay, anyway, but for time being, we will see some of the examples. Here, the most important concept under this one is, okay, there are some particular type of questions which we need to observe. What are those questions? See, 2 to the power of 83 by 83. There is a question in this manner. 2 to the power of 83 by 83. Right? Actually speaking, can we write the any power? Tell me what is the power which is nearer to 83? What is the power which is nearer to 83? We will check once. 2 power 1 is 2. 2 power 5 is 32. We all know. 2 power 6 is 64. And then next 2 power 7 is 128. So, we do not have any power of 2 which is nearer to 83. Then how we are going to solve these type of questions? How we are going to solve this type of questions means, here we will have a person called Euler and we will take the help of that Euler's remainder. Euler's remainder. We will take the help of the Euler's remainder. What is this Euler's remainder? What is this Euler's remainder? This is remainder. What is this Euler's remainder? What Euler says is, any number of the form a power n by b, a power n by b, okay, where a comma b are coprimes. Any number is of the form a power n by b, where a comma b are coprimes and n is the multiple of Euler number of b, and n is the multiple of Euler number of b, then the remainder is 1. So, 1. Remainder is 1. So, that is simple. A and b should be coprimes and n should be the multiple of Euler number of b. What is meant by this Euler number? Okay. So, if any number is of this form, then we call that as, then we get the remainder as 1. Now, what we need to understand is what is the Euler number here. Next, Euler number. We need to understand what is meant by Euler number. With an example, I will let you know so that it becomes easy. Take example 12. There is a number 12. So, what is the Euler number of this 12 means? We need to write all the numbers below this 12. So, what are the numbers below this 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. I need to write all the numbers below this 12 and I need to check with how many numbers 12 is becoming coprimes. Please see here 1 and 12, yes, coprimes. 1 and 12 are coprimes. Why? Because their HCF is 1. 2 and 12, these two are not coprimes. Why? Because HCF is 2. 3 and 12, not coprimes. HCF is 3. 4 and 12, not coprimes. Why? Because 4 is the HCF of 4 and 12. 5 and 12, yes, coprimes. 6 and 12 are not coprimes. Anyway, all the prime numbers will by default become co-primes, some of the cases. Next, in some of the cases, not all. Next, in 8 and 12, the HCF is what? 4. So, that is also not possible. 9 and 12, the HCF is 3. So, that is also not possible. 10 and 12, HCF is 2, not possible. With 11, yes. So, the Euler number of 12 is 4. Euler number of 12 is 4. The Euler number of 12 is 4. Okay, superb, sir. The number, in this manner we will write the Euler numbers. Euler number means nothing but the number of numbers, okay, which are below the given number are co-primes with the given number. Okay, like this. We call that as Euler number. For example, if my question is some 200. If my question is some 200, then how I can find the Euler number? I need to write all the 199 numbers, and if I want to check, it will waste a lot of time, right? It will waste a lot of time for me. So, to avoid that, we have a shortcut method to find the Euler number. What is that shortcut method? Means, do the prime factorization of the given number. What is 12 we have? 12. If you do prime factorization, what you will get? 2 square into 3, right? We already seen how to do the prime factorization earlier. So, 2 square into 3. So, now the Euler number, how you will calculate is, Euler number is equal to, see, if 2 is not a co-prime with 12, then all the multiples of 2 will not be co-prime with 12, right? That is the concept. That means every second number will not be multiple of or co-prime with 12. And similarly, if 3 is not a co-prime with 12, all the multiples of 3 are also not divisible with 3, right? So, 12 into 1 minus 1 by 2. This 2 into 1 minus 1 by 3, 1 by 3. Okay, 12 into, why? Because forget about the power. If it there, even we have 1 power also enough for us. So, 2 and 3, irrespective of the power, we will not bother about power. So, 2 and 3 are there, right, for me, 2 prime numbers. So, 1 by 2 minus 1 by 3. For example, if I have 5, for any other number, I will write 1 minus 1 by 5. Okay, so now what happens to this? 12 into 1 by 2 into 1 by 3. Okay, so 2 ones 2, 6. Sorry, here you will get what? 1 by 2, and here you will get 2 by 3. Sorry, my mistake. 1 minus 1 by 3 is 2 by 3. So, 3 ones 3 2's. So, what you will get here? 4. So, the Euler number of 12 is 4. Similarly, we will check for 200 for once for your clarification. So, 200, when you do the prime factorization, 200s, 250s, 225s, 55s. So, that means I can write 200 as what? 2 cube into 5 square. So, to write the Euler number of this one, what I will do? 200 into 1 minus 1 by 2 into 1 minus 1 by 5. 1 minus 1 by 5. 1 minus 1 by 5. Here I am not writing 3. The reason is I don't have 3 here. Okay, so what you will get here? 200 into 1 by 2 into 1 minus 1 by 5. What you will get? 4 by 5. 4 by 5. 2 5s 10, 0 0 get cancels. So, 24s are what you will get? 80. 24s are what you will get? 80. So, the Euler number of 200 is 80. That means, from 1 to 199, if you check with 200, there are 80 co-prime pairs. There are 80 co-prime pairs. Really good, super. Now, from this we will draw a technical point. What is the technical one is? See here, what is the Euler number of any prime number? Let n be a prime number. Let n be a prime number. Let n be a prime number. What is its Euler number? Means n minus 1. Am I correct or not? N minus 1 will be the Euler number of any prime number n. The reason is, see, in the given two numbers, out of these two numbers, if one number is prime number, obviously those two numbers will always become a co-prime. That is the reason for any prime number, its Euler number is n minus 1. Now tell me what will be the Euler number for 19? Euler number for 19 will be 18. So simply 19 minus 1, 18. What is the Euler number for 29? It will be 28. 1 minus that number. Why? Because those numbers are prime numbers. So, for any prime number, the Euler number will become what? Minus 1, n minus 1. If the number is n, then its Euler number becomes n minus 1. So, this is the concept of Euler number. Euler number means nothing but all the co-prime pairs which was formed below that given number, we call that count as Euler number. Okay, that is the thing which we have done here. And to calculate the Euler number shortcut, I have told you the process also. For any prime number, its Euler number will be n minus 1. For any prime number n, its Euler number is n minus 1. Okay, good, super. Now, we will come to our concept. Now, what Euler's remainder is? The remainder for a power n by b is 1, where a comma b are co-primes, where a comma b, or else directly you can write, and n is a multiple of Euler number of b. N should be a multiple of Euler number of b, then the remainder is 1. Now, we will come to our actual question. What is our actual question? We have here 2 power 83 by 83. This is the question we have. Now, if you observe carefully here, okay, 2 and 83 are what? Co-primes. 2 and 83 are co-primes, and 83 is a prime number. 83 is a prime number. Now, tell me what is the Euler number of 83? Euler number of 83 is 82. So, what I will do is, intentionally I will write this number as 2 to the power of 82 into 2 to the power of 1 by 83. Now, please see here, this n is multiple of 82 only, right? 82 is a multiple of 82 only. 82 once is 82. So, that is the reason. The remainder for this is what? 1 from the Euler's remainder concept. 83 is a prime number. So, the Euler number of 83 is 82. So, n should be a multiple of that 82, right? So, 82 is a multiple of 82. 82 once is 82. And the remainder for 2 power 1 by 83 is 2. So, into 2. So, the remainder will get what? First here 2. So, there are some difficult questions from this remainder concept where we will take the help of the Euler's remainder, right? With this, we are going to end this session. In our next further sessions, we will discuss the problems from this units concept, reminders, and all the leftover things from this number system, right? Thank you very much. Thank you.